So the order these are on your review are the order that they're going to be on your final. If I were you, that's the order that I would put them in your notes as well. So we did a lot of completing the square by to find the vertex. The main thing that you guys need to know moving forward is the equation of the circle. So that is the last way this is going to be tested. And it's just basically doing the same thing twice. We split this into two parts, recognizing that we do have that equal sign there. And I'm going to get rid of some of that. What we need to do is look at this in terms of what would make this a perfect square trinomial. So if I have x squared minus 8x plus something, that something is what would make it a perfect square trinomial. So if I write that in that factored form for just the x's, I'm ignoring the y's for now, what am I looking at for what goes in those parentheses? X minus 4. And how did you get that? Took half of that negative 8. So that term right there, you take half of that term, and then what do we do to get that term?
Y plus 8?
No, we got to complete the square on the first part.
You're right. 16.
And how did you get the 16?
Negative 4 times negative 4.
So square that number. So we got a 16 there. Now, we can't just add this and add it once and pretend that that's an okay thing to do. Mathematically speaking, if you do one thing to one side of the equation, you have to do the same thing to the other. So we're also going to add this 16 over on the other side of the equal sign. So everything we've done there is mathematically legal. We took this part of the equation, we completed the square, and just rewrote it in an equivalent form. And then that 16 we added, we also added over here. So with the y's, once again, and I'm going to take a little more space here, y squared plus 16y plus something is going to give me a perfect square trinomial. So if I take half of that 16, what am I going to have in the parentheses? Y plus 8 squared. I want to drop down that plus sign. So what is my blank spot going to be? What is this going to be right here? 64. So if I add that 64 here, I also have to add it to the other side of the equal sign. So I'm going to take all three of these, negative 44 plus 16 plus 64. I'm going to add those together to get what?
36.
Thank you. So we have completed the square. We have this in the standard form of a circle. So to remind you what that equation is, it's x minus h squared plus y minus k squared equals the radius squared. So hk is the point hk is the center of the circle, and r is your radius. So what is the center of this circle? 4, negative 8. Whoops, not 4 minus 8. So to remind you, because this is a negative, this is minus, and this is minus, h is just 4, not a negative 4. Over here, because in our general equation, it's y minus k, and this is y plus 8. We have to have a double negative there to make it a positive, so that's why our k is a negative. And then what's our radius? 6. Take that square root of 36 to get a radius of 6. Sorry. General equation for the hyperbola is y equals a times 1 over x minus h plus k. So the locator point, what piece of information does that give us?
H squared.
h and k. And the passing through point, what piece of information does that give us? X and y. So I plug in everything I know, and then I'm going to solve for what I don't. So my y value is 6. I don't know a. My x value is -2. Don't forget it's minus h. My h value is -3, so I'm going to make that a +3. And then plus k, not k, 4. So then I need to simplify and solve. So 6 equals a times 1 over just 1 plus 4. And the 1 on the denominator, that's just the -2 plus 3. I'm going to go ahead and replace that with just 1, partly to show you process on this. Can I add the 1 and the 4? No. Why not? Yeah, a is attached to that 1. They're being multiplied, and you're adding 4, so you cannot combine those two things. So you need to get rid of the 4 first. So -4 from both sides of the equation. So I have 2 equals a times 1. Because a is 1, I don't really need to divide by 1. If it was anything else, I would divide by it to get rid of it, to get a alone. But since it's 1, a equals 2. So my exact equation, y equals 2 times 1 over x plus 3, and then plus 4. So I have my a and my h and my k substituted in for my final equation. Completing the square. For the circle specifically, that was AA 1-10, and that was October 17th and 18th. I want to say 8 or 9 will also have it, but it'd be towards the end of the video. Exact equations for the parent graphs, that was AA 1-7. And we did that on 10-3. Okay. As I mentioned before, parent graph stuff, that can be any of the things on your parent graph toolkit. This particular one is a cube root. It's really unlikely you're going to see a cube root on your final. But the idea is the same. What I'm going to do first is I am going to draw in a lighter color probably, what the parent graph for the cube root is, and then we're gonna move the locator point. So the parent graph for the cube root has a point at 0, 0, goes up 1 and over 1, and down 1 and back 1 in both directions. And then it comes way out, it goes up and down 1 and then out 7. Yeah. And that comes down to, the reason that is what it is the cube root of 1 is 1, and then there's not a perfect cube root until you get to 8. The cube root of 8 is 2, so that's why we have that big stretch between those. Jason, stay with us. So that's the parent graph of this. And when you were drawing these, you need to draw the points, at least the ones that fit, especially with cubic and cube root, they don't all fit. But those specific points need to be pointed out. I don't need you to write the coordinates or anything like that, but I need it to be clear where those points are, because some of these graphs are hard to draw accurately. So if you have the points drawn where they're supposed to be, but your graph doesn't look beautiful, then it's easier for me to grade. So my locator point needs to be moved to where? What is my locator point on my transformed?
Over 2, up 3.
Yep. The locator point is 2, 3, so I'm taking that point and I'm going over 2 and up 3. So I'm taking this entire graph and I'm moving it up and over. So I'm going to undo that drawing so it's not all jumbled up. So over 2 and up 3, that's now my center point. And the pattern with it stays the same. So I'm still going to have the up 1 and over 1, and the up 1 and out 7, and the down 1 and back 7, and that is my new graph. And that's what I mean, like what I just did is kind of a good illustration of why it's good to have those points there, because just drawing that curve is not that easy. But if I see that those points are all in the right place and you have this right general shape, that's what I'm looking for. Okay, so on to piecewise functions, which I know is everybody's favorite thing. What I'm going to do first is take my domain restrictions and put my boundaries in. So I know because of the domain restrictions on the right, so everything over here, that I'm going to have a boundary at -3 and another one at 5. And all that boundary does to my lines is tell them where to get cut off. That's it. Doesn't tell them where to start and end, or like where their placement is. It just tells them where they get cut off. So at -3, I'm going to draw a vertical line to show that's where one of my boundaries is, and then another one at 5. So I'll do this first one. I don't want that in highlighter, sorry. I'm going to do the first one in red. X plus 4. What is my y-intercept of the line x plus 4? 4. So y-intercept of 4. And what's the slope? It depends on which way you're saying over. So it's up 1 and over 1 because the slope is just 1. And when we go up 1 and over 1, we always go to the right. Part of the reason that this tends to throw people off is because where I start this on the y-axis here, this line is going to be cut off. It's not in these two boundaries. So what I have to do is go down and back and down and back and down and back, and that's where my boundary is going to be, and I have the wrong kind of circle there, for this particular line. So down and back and down and back. And the parts of it in the middle between -3, why are you letting me erase some of that, not all of it? Between -3 and 5, I'm not going to keep. So I'm going to have an open circle here, and then this one just continues back. But the fact that the y-intercept was 4 doesn't change. The boundary doesn't give you a new y-axis. So it's important to remember that, because a lot of people have a tendency to want to start at 4 on the boundary and then go back 1 and down 1, and you need to be careful about that. Questions on that part? Okay, on f of x equals 4, what kind of line is that going to be? Straight, horizontal. So it's going to be at 4, and this one goes between -3 and 5. Let's do that one in blue. So it's just going to be a flat horizontal line between -3 and 5. What type of circle do I need at -3? Closed, because of the or equal to. And then at 5, that one is also closed. Questions on that part? All right, and the last one, what's my y-intercept on -2/3 x plus 6? 6. So I'm going to start it at 6. And then where do I go from there? Down to over 3. So that's going to be my next point, down to over 3. This one is not going to cross at an exact grid line. So basically what I want to do is pretty much just start it there and continue it out down 2 over 3. So I'm going to undo these parts to get that green off of there. Now I lost it. 6 down 2 over 3, down 2 over 3, and down 2 over 3. And then what type of circle do I need on my boundary? Open. Questions on that? So keep in mind, for those of you who really did not like piecewise functions, one of your options with that page of notes that is thorough and the review that I'm going to give you today being completed, if piecewise functions just never stuck with you, that could be the one that gets excused if you meet those 2 requirements that we talked about last class. Piecewise functions, that was quite a long time ago. We did that that was AA02, and that was September 9th through 13th in that region. The parent graph transformation, that was AA1-6. There's 2 videos on that. One goes over just the parent graphs and how they're created, and the other goes over the transformations of them. That was September 28th and 29th. So if you're looking at the calendar, that's why I'm giving you the dates. So let me make that correction. That shouldn't say graph, that should say equation. So remember, the idea in solving them is the same as the parent graph. Plug in what you know and solve for what you don't. The setup for how you write your equation is different than the parent graphs. Polynomials were focused on the roots and the factors that are involved with those. So if I have crossing roots, do I have any exponents on those factors? No. Bouncing roots and flat roots, those are going to have squares and cubes respectively on those, but this one is just crossing roots. So I have, for a basic equation, I'd have y equals a. What is the factor associated with a root at -3? X plus 3. And then at 1, at positive 1, that factor is going to be x minus 1, and then at 4, it's going to be x minus 4. So this point right here, the passing through point, that gives me my x and y. So I plug in 24 for y. I don't know a, that's what I'm solving for. Plug in 0 for all the x's. And then I'm going to simplify and solve. So I have 24 equals a. And here's the important thing to remember when you get to the overall solving. All these things are being multiplied. A is being multiplied by 0 plus 3, by 0 minus 1, and by 0 minus 4. So at no point over here do you need to start adding in pluses or minuses where they don't go. Remember that all those factors are being multiplied. That's the definition of a factor. So simplifying that, we have 3 times -1 times -4. So important to keep those parentheses around them so you don't think that you're supposed to start subtracting. It's a really common mistake. So what is 3 times -1 times -4? Positive 12. And as always, watch out for those negatives. So a times positive 12. And then what do I do to solve for a? So a equals 2. So my final exact polynomial equation y equals 2 times x plus 3 times x minus 1 times x minus 4. And one of the things that I intended to do and then just totally blanked it was to tell you guys what sections and the dates that these were. So exact polynomial equations, that was section AA 3-3. And we did that on November 2nd. And I don't know if that's an A or B day, but that's the space it was. So let me jump back to the other ones really quick. And those are on the review key. I just wanted to make sure you guys knew that. So basic polynomial graph. We did that. That was AA 3-2. And we did that on November 1st. So on a problem like this, you're looking at a couple things. You're looking at what your roots are, what types they are, and what your end orientation is. So whether the end direction on the right side, the phone's away, is going up or down. So this particular one, is this one going to be going up or down? Yep. So because of that negative, this is going to end down. For x plus 3, what type of root is that? Crossing, because there's no exponent. So that's just a crossing root at positive or negative 3? Negative 3. So that's a negative 3 crossing. What's the next one? So the next factor is x minus 4 cubed. Where is that root going to be and what type will it be? Positive 4, and it's going to be flat. And then what about x? Yeah, it's a crossing root at 0. So a lot of people tend to miss that one. Make sure that you know that is there. So one of the things that people have a tendency to do with these is to try to, as they're doing this, they'll go, okay, that's supposed to go flat, but I have to cross back this way. You just created another root there that is not in the equation. So make sure that you're not creating a root that is not consistent with your graph, or sorry, with your equation. So one of the reasons I recommend you start on the right side and go backwards is because if you know your end direction and you do everything correctly, then your starting direction will just work itself out and you don't have to worry about which way your starting direction is. So if I know this is going to end down, then I'm going to start down here and go up, flatten out there. And if your flat roots don't necessarily look like flat roots, just point an arrow to it and say that's flat. So I know that you knew what you were supposed to be doing. And then it goes up. We have to turn it around to come back and cross at 0. We have to turn it around again to come back up and cross at negative 3. And that is the basic polynomial graph. But the problem you had on review A, once you got it down to a quadratic, it was x squared plus 9, which has imaginary roots. That was not my intention. I took it from another test review. The fully factoring higher degree polynomials will be fully factorable without imaginary roots. How you go about this is kind of up to you. I'm going to do the area model to factor this. If you're comfortable with synthetic division, I would just recommend synthetic division. It's faster. But you can't use it on factoring the quadratic, so make sure you know how to do that part. Most common mistake, put the phones away, please. Most common mistake on this is people using, getting confused between the root and the factor. So if I have a root at positive 4, at x equals 4, what is my factor? X minus 4. So when you are doing these problems, depending on the type of division you're using, the area model and long division both use the factor, the x minus 4. Synthetic division uses the root, and it's important that you know that when you need to change that to an x minus 4 as opposed to using just the x equals 4. And that is something I know based on having graded the previous tests that several of you need to have in your notes, that the root and the factor are different and you need to know when to use which one. So on the area model, we use the factor. So I'm going to set this up with the box. And put x minus 4 over here. I'm going to start with my first term, 2x to the third, in that first box. And then I go through the process of factor, multiply, subtract. So the first thing I'm going to do is factor x times 2x squared gives me 2x to the third. My next step is to multiply. Let me zoom in on that bit for you guys. So 2x squared times negative 4 gives me negative 8x squared. And as I said, this is not the problem that is on your review because I wanted to show you guys one that's fully factorable without imaginary roots. So then what I know is that these two terms are going to add up to give me that 5x squared. So that's where the subtraction comes in. I take the 5x squared minus the negative 8x squared. So I'm adding. So 5x squared plus 8x squared gives me 13x squared. So that was my factor, multiply, subtract. I'm going to do that again. So factor out a 13x here. I'm going to multiply 13 times 4, which is 52. So negative 52x. And then I'm going to subtract again. Negative 46 minus a negative 52. 6, right? So 6x. Factor out again, factor out that 6, multiply again times negative 4 to get negative 24. These two should match if that is a factor. So that is my partially factored form, x minus 4. And you don't have to write this part down, but x minus 4 times 2x squared plus 13x plus 6. Now I need to take this quadratic and I need to factor that. For most people, they're most comfortable with the box and diamond for factoring that. So I'm going to go through that process. And if this is a process that you're not comfortable with, make sure you're writing stuff down. So with that 2x squared plus 13x plus 6, I start with my first term in the lower left, last term, upper right. And what do I do with those two terms? Multiply them to get that top number. So those multiply to get 12x squared. And then on the bottom, 13x. So a problem like this actually very often throws people because when they're thinking of factors, the one that they tend to forget if they don't list them is the 1 and the 12, the 1 and that number. So I can list all my factors. I don't need to, but in the process of figuring out what numbers are my side numbers, I can list all of the factors as the 1 times 12, 12 divided by 2 is 6, 12 divided by 3 is 4, 12 divided by 4 is 3, where I can stop. I could have stopped a step before because my factors were flipped. The pair I'm going to use to add up to 13, 1x, and 12x. And then once again, in terms of this fully factoring, you got to be careful where you divide out a 2x, where you factor out a 2x. So this row right here, what's the greatest common factor for 2x squared and 1x? What are both of those divisible by? 1x. And that's all I can take out of that is just the x. For my column, 12 and 2 are both divisible by 2. So that's where I can take that 2x out. So 2x. 2x times 6 gives me 12x. X times 1 gives me 1x. And then I double check. Always double check this because that's a good way to know if you made a mistake, that these two numbers are multiplying together to give you that one. So 6 times 1 does in fact give you 6, so you know you've done everything right there. Or at least if you made a math mistake, you made the same math mistake a couple times. So fully factored form, I take the factor I started with, the x minus 4. That was my first factor. My second factor, doesn't really matter what order these go in, but x plus 6 from the side, and then 2x plus 1 from the bottom. That is my fully factored form. Then my roots need to be everything that makes, anything that makes those sets of parentheses 0. So the first couple are pretty straightforward. X minus 4, that root is going to be 4. Huh? Oh, that's what I'm talking. X plus 6, so what is that root going to be? Negative 6. The last one, though, a lot of people jump to thinking that's just negative 1. But if you were to plug a negative 1 in for that x, you would get negative 1. You wouldn't get 0. So what you want to do is set that 2x plus 1 equal to 0. And if you can do the math in your head, that's fine. But if not, then write it down. So you've got subtract 1 from both sides. 2x equals negative 1, divide by 2. So your final root is x equals negative 1/2. Forgot to start recording that. That with the remainder theorem, you're using the actual root. You're not swapping the sign on that because you don't need to use the factor. So we took that 3, plugged it into our equation for all of the x's, evaluated the exponents. So now I'm going to evaluate the multiplication. So 2 times 27 is 54, minus 7 times 9, which is 63, plus 18, and then minus 3. And at that point, I would just put it all in your calculator, 54 minus 63 plus 18 minus 3, and what did you get? 6. And then you need to verify this using either the area model, which we did on the last problem, synthetic division, or long division. I'm going to go ahead and use synthetic division for the interest of time. With synthetic division, you also use the root, so I'm just going to put the 3 there. And then I take my Then I take my coefficients from the polynomial, so the 2 in front of the x to the third, the negative 7, the 6, and the negative 3. And that's my setup for the synthetic division. Heads up, guys. Okay, so I'm going to drop down that 2, multiply 3 times 2 to get 6. And this process is just multiply, add, multiply, add, multiply, add. That's all it is. Negative 7 plus 6 is negative 1. 3 times negative 1 is negative 3. 6 plus negative 3 is 3. 3 times 3 is 9. And negative 3 plus 9 is 6. And that's how you verify this, is that this number and this number are the same. The one you can't see because I have zoomed out too much, or zoomed in too much. So those two should be the same. That's how you verify your answer. Any questions on that one? Okay. For fully factoring, that was AA35. And you can't see that. That was on November 27th. And then The remainder theorem was AA 3.6, and the worksheet was 3.6b. I don't remember if the video is 3.6b or not, so I apologize for that. And then that's 11/29, November 29 is when we did that one. So that's where you will find that instruction. And then we are up to our most recent material, which is the complex numbers and complex solutions. This is not a whole lot of stuff. This is already written up here, the 3.7 and 3.8. So that was just recently. That was just in the last couple of days of class. So the most recent thing on the calendar is what you're going to find there. So main thing that you need to know with this stuff is that I is the square root of -1. And so that means that I squared is -1. You need to make sure you're really clear on that, because if you're starting to think that I is -1 and you're not getting those specifics in there, then you're not going to get this right. Jeremiah, are you with us? Okay. So, I am going to zoom in over on this part where more mistakes were made with this one. So if I have 8 plus I times 8 minus I, a few ways to go about this, and there certainly are some shortcuts. Feel free to use them. But the lower your understanding on this, the more steps you should be showing. Because if you try to jump steps, chances are you're going to miss a negative. And as I've told you guys before, if you're missing a negative, I don't know if it's because you didn't understand I or if it's because you just missed the negative. So keep that in mind. And I don't know if I mentioned in this class or not. So I'm multiplying each of these little sections, and then 8I, negative 8I, and then what is in that final box there? Negative I squared. And that's where the mistakes happen with the negatives. So what do we know I squared is? -1. So if I have negative I squared, that is the same as negative -1, which is a positive 1. So 8I and negative 8I add out to 0. So what I'm left with are 64 plus 1. So my final answer, 65. Questions there? All right. With the x plus 3i and x minus 3i, I'm going to go ahead and use, sorry, I got to move this over to write on it. I'm going to go ahead and use the just the FOIL method. X times x gives me x squared. X times negative 3i is minus 3xi, or ix, it really doesn't matter, plus 3xi. And then this last part, what is that going to be? Yep, minus 9i squared. So a couple things to remember here. Once we've multiplied out, we are adding to simplify our like terms here. So negative 3xi and positive 3xi, those add out to 0, so I can get rid of those. So what I'm left with is x squared minus 9i squared, and that is not a fully simplified answer. So what do we know I squared is? -1. And then -1 times -9 is what? Positive 9. So I've got x squared plus 9 for my final answer. Question? So the question that just came up is, can you take the square root to simplify that to x plus 9? And the answer is absolutely not, or x plus 3. So there's two reasons you can't. One is this is not an equation, so we can't square root both sides to simplify or to solve. The other reason is you cannot square root an addition or subtraction problem and square root both parts of it. So you can't square root x squared plus 9 to make x plus 3. Those are not equivalent things. Think of it in terms of the Pythagorean theorem being a squared plus b squared equals c squared. The squareds have to stay with it. You can't just make that a plus b equals c by square rooting both sides. So that's as far as you can go with that one. And that's as simplified as we want it. Other questions? All right. The arithmetic, actually I'm going to move the screen. We have 3i plus 7i. When it's just I and it has not been squared, we treat it like we would any other variable. We treat it like x or y or anything else. You combine your like terms, and what are not like terms, you can't combine. You just leave them as they are. So 3i plus 7i, whoops, is 10i. I don't want that in yellow. 9i minus 12i. 3i squared. What is the unsimplified version of that when I apply that square? No? What exactly is being squared on this one? And the 3, because it's in parentheses. So it's 3i in parentheses being squared. So this is actually 3i times 3i, which if I wanted to rewrite it, whoops, that's not what I meant to do. Can just be 3 times 3, so 9, and then I squared. So that entire thing in parentheses is being squared. The I squared then becomes what? Negative 1, so 9 times negative 1, negative 9. And then 12i to the third, is the 12 being put to the third power? No, and how do we know that? Because it's not in parentheses, it's out in front. So this is 12 times I times I times I. Those first two i's can be represented as I squared, which is what? Negative 1. So 12 times negative 1. And then that last I has to be dropped down and then treated just like any other variable because it's just a single I. So that would be what? Negative 12i. Start with the full quadratic. That one you need the quadratic formula for. So that is x equals negative b plus or minus the square root of b squared minus 4 ac. The square root goes over the whole thing. All divided by 2a. If you don't have that on your notes and you don't have it memorized, you should add it to your notes. I had it on the board during the test that I didn't allow notes on, but since I am allowing a sheet of notes on it, you should take responsibility for that. Our a value on this particular equation is what? 1. And our b value, 10, and c, 26. So we plug everything in. Keep in mind, this is complex solutions. That means your answer should probably have an I in it. So that should be a heads up to you that should be the case. So x equals negative, from the formula, 10 plus or minus square root of 10 squared minus 4 times 1 times 26. All divided by 2 times 1. If these problems look vaguely familiar, they should. This was your last test, just FYI. So x equals negative 10. I'm just getting rid of the parentheses there. What do I get when I do 10 squared minus 4 times 1 times 26? Negative 4. I guess I don't need the square root sign quite that long. And then all divided by 2 because of the 2 times 1. So, square root of -4, this was, a lot of people got to this point and then they didn't know what to do. So the square root of -4 can be, whoops, that needs a negative, can be separated into the square root of 4 times the square root of -1. The reason that separation is helpful is to get us out of the square root of a negative number. In your fully simplified version, you should have no negatives under a square root sign. Those should be represented with I somehow. Square root of 4 is 2. Wow. And then the square root of -1 is I. So basically, we're taking this square root of -4 and we were replacing it with that 2i. So when we write this, x equals -10 plus or minus 2i, all divided by 2. You can leave it there if you prefer. Fully simplified would be both -10 and 2i are divisible by 2. So x equals -5 plus or minus I. That's your fully simplified. Questions? Those are your actual roots. They're just imaginary. That's as far as you can go. -5 plus I and -5 minus I. Questions? Yeah. So same idea with this one. We do not have to use the quadratic formula with this one because we have just an x squared to isolate and not an additional x. So to get rid of the things surrounding the x squared, we're going to subtract 125 from both sides of the equal sign. It's got -125 equals 5x squared. I don't want to square root yet because then I would be left with the square root of 5, which is not a whole number. So I'm going to divide both sides by 5. So I'm left with -25 equals x squared. And then that's where I square root. Square root of -25 simplifies down to what? 5i. And if we're being really technical, it's plus or minus 5i. Whenever you're solving square root to solve, it's a plus or minus. If you don't have that plus or minus, I'm not going to count it wrong. So that's it. That is your final review. I have a second review for you. The review B, I'm going to post that, or I'm going to give that to you guys in a moment. The review B, so guys, remember to get one of your skills, so the 2 skill tests for a single skill for a given, you have to have that set of notes completed with more than just examples, as well as review B completed and checked. Because you guys have one more day in class, I'm not going to post the key to review B. You have to show me a completed review, and then I will let you see the key. But I want you to make sure that you're checking your answers carefully to that and that you are learning from any of those mistakes. Make sure as you're working on your review as well, you're writing down those things that you don't know off the top of your head. If you don't know the quadratic formula off the top of your head, add it to your notes. If you keep forgetting that I squared equals -1, add it to your notes. Anything that you keep forgetting, anything you had to look up, put it on your notes. Especially the parent graph stuff. Unless you have those memorized, get your parent graphs on your note sheet as well. Any questions? Mm-hmm.
This is how long it will be.
Yep. The only addition to the actual test is that the complex numbers parts will have a highly proficient on it as well, because it's just your second round of taking that one.